Right, now to assemble the bits and pieces back inside the differential. So we have there's a thick shim that went on the outside, a thin shim went on the inside one. Just light coat of grease and everything. Probably best to run these on a fairly fluid grease rather than oil. The oil tends to run out through the sealed bearings. The seals sometimes don't stop oil coming out, stop grease. So a fairly fluid grease is useful. So that's the first sun gear washer in. This is the cross pin, a grease. Just make sure everything's greased up on assembly, because you never know how long these things are going to lie about. Line that up with the 4 slots inside. It should simply drop in, as they say, if you line it correctly. Not quite right yet. That's it. That's in. Again, the sun gear in here, got a good coating of grease. A bit on the splines. A bit round the outside. And right to the thick washer. A light grease as well. Sits on there. Nice greasy fingers. Just get this on the bearing surfaces in here, which is just on there. Don't want to get any on the outside flange because I'll be putting sealer on that. Once we get the hands cleaned. Somewhere around there will be a little notch, which is the orientation of this. There should be a corresponding one there. So that's where it assembled. I'm just going to use some Hylamar blue non-setting gasket on this face here. Stops any grease coming out through the do. There's a notch there, and I said the notch was over here somewhere. There's a notch there. Two screws hold it together, and obviously the other 10 screws will clamp that together when the sprocket goes on. Cooling down there, that's it. So that can slips on there. You have to machine the end of it to fit over the spigot, and you machine it to length. There will be a ring, an aluminium ring that diameter, that will bolt through from that side. It will project a little bit, in fact it will be that diameter, because there will be the mountings for the sprocket along the outside, and the sprocket's going to sit on that outer rim, and then there'll be a slot or a recess in the plate to take the oil can and seal it. So this will need to be shortened slightly to suit the ring that I make. It will be made from that billet of aluminium, piece of 7-inch diameter, 25mm thick alloy. So that will effectively be about there. The sprocket bolts through from this side. Just taking off the little oil throwers off. Just a place to get rust right in the corner there, which you don't want. See one of these crack across there where it's been rusted in the past. Take out the circlip. Attempt to take out the circlip here. Then just wire brush off the worst of the rust and give it a look at it. So the worst of the rust taken off. There's still a little bit of surface rust on the faces there. I'll put them in the lathe and just skim that face just to take the last of the pitting off. And then I can press the studs back in. I've cleaned up and painted the output shafts for the MX5 diff. You'll notice the LSD MX5 viscous coupled diff uses two different output shafts. That's the left hand side one, and this is the right hand side one. The right hand side one goes through the sun gear and then into the centre of the viscous coupling, and this side goes into the outer of the viscous coupling, which is also acts as a sun gear on the opposite side. So they're all faced off and painted and cleaned up. There's a circlip goes in there, and then a circlip goes in there that holds them in a snap ring. Anyway, internal snap ring locks in place when you push them in, and then there'll be an oil seal running that journal face there. I've used my centre finder to find the centre of this billet of aluminium. It's not perfectly round, so they take a few scribes at it, average where the centre of the hole is, and put a centre punch in. So I'll be able to now drill a hole in the centre and tap it, and then mount it on an adapter that I've got from my lathe. So I'll be able to machine one side down to a size I can grip on, and then bore out the rest of the centre. This is the adapter that will hold in the chuck of the lathe. An M10 thread that screws straight on there. Tightens up. Just tighten that fully. Hold it in the lathe and be able to face it off and turn it down to size. You can see it's got a bit out of true way up and down, but it's not drastically out of true. And machine this, the face that mounts against the crown wheel flange will have about 10.5mm flange to bolt the sprocket to, and then it will step down to a size that will take the oil can in it plus about 3mm either side of that to support it. So I shall go and establish what that size is, and then turn this down to the finished size there, so I'll be able to grip it on that face when I turn it round about, and then bore it out to the diameter I require and face off the other side. So I've just screwed on the back. Need to get my little adapter. Right, this needs to be about 10mm, we said. Oh, that's pretty much close. Just clean the face up. Set up in the rotary table to drill the mounting holes that will go onto the differential. In fact, I want to drill them the opposite way around, I think. Do that. Yes, I want to put an almost blind hole there, because otherwise I'll be starting to eat into that rim with the 10mm on that side. Right, so I'm set up to drill 114mm PCD. I'm going to drill 8 holes in there. On the rotary table, it's 4 degrees per turn. And I need to, for the 8 holes, I need to do 11 full turns plus 1 degree for every hole. So I just need to keep count when I'm drilling the holes. I'm going to put a pilot hole in. Right, for the next set of holes will be further out. I think they're on 160mm PCD, and I'll stagger them halfway between these ones. Unfortunately, I haven't got a collet from a tapping drill size for the M10s, so I can't hold it in here. I do have a drill chuck, but it's a lot longer, sticks out about that much before you start, so you don't get any room for a drill. So I'll need to do that on the pedestal drill. Drill these out to the depth I require and then tap them. And the same, drill and tap these M8 on the outer ones. Well, that's the ring that seals the oil can on and locates the sprocket. I'm just putting the M10 bolts in there temporarily while I measure the depth so I can machine the oil can inside. I should hold it on. Yeah, take it about 58. I need to go and machine down that face to step down about a millimetre to give me clearance from the oil can to the bearing that goes on there, and cut down this face so that it rests on that face there. The inside of the can sits on there. That's the oil can machined. And I've got a step of about a millimetre there to give me clearance from the bearing on the bearing carrier, and it's been drilled and tapped for the grease fittings. Not screwed them right in at the moment because they won't slip on there. Just back them out a bit, and then that goes down in there and it gets sealed on with polyurethane sealant round here on the inside, and inside that lip there. I'll get this all degreased, take this off, put a bit of sealant behind the flange and into the groove, seal that on, drop it on and let it cure. Put these in temporarily. So once the adhesive's set in there, I'll take them out and put some Loctite on them. So next, put a generous dollop around the top. Doesn't really matter, it gets into these recesses. The sun gear is greased up well enough that it will slip round on the adhesive. It should stop the leaks. Right. Put a wee bit on the inside and outside of this just to be doubly sure. Right, line up the grease nipple holes with the ports and push it in. That's fine. Just leave that to cure. Our sprocket goes on there. And on this side, once I've tightened those up, I'll also put on an eye lock lock washer which will double lock the bolts in place to stop them backing out, because you really don't want the sprocket coming loose. Temporarily put those two on. Right, well, I'll leave that to cure. In the meantime, I'll go and machine the bearing carriers to go on both sides. That billet's a 5.5 inch by 2 inch billet of aluminium. It's right on the limit for the jaws of this lathe. It's supposedly a 5 inch, but it will just squeeze a 5.5 inch block in and no more. It just grips on about the last thread of the jaws. I don't have a power cross feed on this lathe anymore. When I replaced the lead screw in here, I did away with the power feed. It was causing too many problems with wearing out the nut the way it was designed. Tightening up the insert a bit, feeling it was vibrating a bit much. Sometimes just adjusting the length of the bar stops the vibration. Just get the wrong frequency. So when the lighter cuts, it was wanting to vibrate. Machining a little bit of clearance for the rubber seal on the back of the bearing. Just in this area here, just get some clearance against that rubber. Fine for the seal, breaking the sharp edge on the step for the seal there. That's that side down. Put some high strength locking compound on the bolts so they don't work themselves loose. Get them all started. Do them. That's the grease nipples tightened up. Next thing to do is we need to put the bearings and bearing carriers on. This side has a 3mm spacer that goes on first because the spigot is a bit longer on this side, and then we press that one there. So I shall go next door and put that on. It's the bearing carriers with the nice new seals and the sealed bearings ready to get pressed in. That's the bearings on both sides. Just need to put the oil seals in there now. I'll lightly grease the shaft and the splines and the oil seal spigot. Like that. I haven't got the circlip on at the moment, so I can take it out easily. Put over. This side has the shorter shaft. This is the left side. There you have it. You can tell this one's a viscous coupled diff. You can rotate the output shafts very slowly in opposite directions. It's working against the viscous coupling in there. Quite stiff. That's the differential complete. Sitting in its bearing carriers with sealed bearings. The side fixings normally bolt into a carrier plate or pivot carrier. This one you can take the sprocket off without taking the bearing carriers off because the diameter there is larger than there, so it will slide off. Still got to take the drive shaft out, but you don't actually have to physically pull bearings out or have split sprockets to get them off. Two grease nipples in there for filling the can in there with oil or a semi-liquid grease. Output shafts have oil seals on them that run on these journals here. I fitted the circlips into the wire clips into the shaft, so when you push them in now they'll lock into position at the back of the sun gears. So if you are just doing a temporary fit up, make sure you take the clips off before you put it in, or you're going to have to hit them with a large hammer to get them back out again. This one has a fairly narrow sprocket on. This is a 525 sprocket. as opposed to a 5/30. So that's a 5/16 sprocket as opposed to the 3/8 sprocket on the other ones. The pitch is the same. The pitch is still a 5/8 pitch. This one's going with a corresponding front sprocket, a 525 15 tooth front sprocket to suit a Kawasaki or a Suzuki, or a Triumph according to this.